In this tutorial, we're going to show you how to take a full 3D model, import it into the software, unwrap it, rewrap it, and then show you how to create 3D tooling for it so that you can cut the part. We're going to start this off by creating a new file. And in our job setup form, we're going to be setting up a rotary job. And the length of our stock that we're going to be mounting into our CNC is going to be 12 inches. And the diameter is going to be 4 inches. Now what our software has done is taken that cylinder and unwrapped it. So cut it down the L, the length, and then flattened it out to give us this job space. Now we're going to go ahead and zero our machine off the cylinder axis, but we do have two choices. We could do it off the surface of our cylinder. If we had a semi-perfect cylinder and we weren't too worried about any imperfections in that cylinder, then we could go ahead and zero off the cylinder surface. For us, we much rather actually set up our machine so that we're using the center of our axis to work from, which is actually as if we were zeroing off our CNC surface if we were doing a flat job. We're going to set our XY datum to the bottom left-hand corner. And now we get to choose the orientation. So what we're going to do is we're actually going to wrap our Y axis around the cylinder. So that's why we're going to choose along the X. Now this will all depend on your machine setup. So if you're not quite sure, you can either call the manufacturer of your machine or contact them. Or sometimes just as easy as looking at your machine and you can tell what axis is being wrapped. So for us, we're going to set ours up for along the X axis. We're going to use a very high modeling resolution because we're bringing in a 3D model. And then we're just going to click OK. Now for our next part of this, we're going to take a look at what our software has done for us during the setup. So if we tile our views left to right, and then we show or turn on our material block, you'll see what we have. Here's the cylinder that we have set up for us. And you can see down the bottom here our job dimensions. We have the width of 12 inches, a height of 12 inches, which is actually the circumference all the way around, or 12.5664, and the depth is half of our diameter, so it's 2 inches up and down. Now what we need to do is we need to bring in some 3D content to unwrap. So we're going to go to our modeling tab, and we're going to import in a 3D component. Now we have a 3D component here for a handle. This was created in Rhino 3D, and unfortunately we can't give this model away because it's one of their demo models, but the information that you'll be able to take away from this should set you up for unwrapping just about any model that you need to. So we're going to select this and we're going to click open. And we're going to maximize our 3D view. And let's look at it right on its Y axis. When we first bring in our 3D component, you'll see that it's placed within inside of this blue cylinder. And this blue cylinder can be considered a bounding box or bounding cylinder for your part. And the software has tried its best to orientate that part in there to give us the best use of our material. It does a fairly good job, but I think that we could take a few more minutes and actually do a slightly better job of getting this to fit in there properly. So we have the blue bounding cylinder, we have the red axis, and then we have a red arrow, and this red arrow points up towards your Z axis where your cutter will come down. Now when we imported in our model, because it was a non-native format, it opened up our Orientate 3D model form. And we can use all of these different options to help better position our 3D component in our material. Now we need to tell it what kind of component this is. Is it a full 3D model or is it a flat model? In some cases, you're going to want to bring in a flat 3D model and unwrap it, maybe to wrap it onto another surface. But in our case, it's just a full 3D model, so we're going to go ahead and select that. Now our initial orientation, we can change it. So right now it's set to top. And we can also do a little bit of rotation. So what we can do is just go ahead and click through these, and we'll pick the best one that suits us. So this is the top. Let's go with right. Obviously that's not the best use of our material. Front, that might be okay. Bottom, that's just the opposite of the top. Left, and then back. So I suspect for us, the best option is going to be to go back with the default again on the top. Now you can also rotate it in different degrees. So you can go 0, plus 90, plus 180, or you can go back and minus 90 or minus 180. But we're going to leave that at 0 for right now. Now we also have an interactive rotation. So right now we have the XYZ clicked for viewing. So if we rotate it, then we're just viewing it. We're not actually moving the part with inside the cylinder. We're actually rotating and looking it all over. Let's look back at our Z again, or our Y again. But if we click X and Y, then we can actually move our 3D model around our rotational axis. And this might be handy to kind of hide it better. So let's just undo that. We'll undo that back to where it was to begin with. And now we can go ahead and try the X. So we can move it on X, so we can move it around in a circle like this if we would like to get a better positioning of it. We can rotate it on our Z axis, which might be handy. Let's just undo that. But for now, we're actually going to rotate it on our Y axis. And what we can do is actually bring this down so that we end up putting our rotational axis inside of our handle the best we can. So if we just click and drag it down the best we can, and let's have a look. And that's pretty good right there. So if we flip back to the view X, Y, and Z, we can rotate around and we can see that at this end over here, it's still right in the center. And at our other end, it's slightly above the center. And it could actually cause us just a little bit of problems. Sometimes this is the best we can do, and you will have a few undercuts that you're going to have to work with, because the software, when we unwrap this, will have to fill in this space between your axis and your actual 3D model with material. So the fewer undercuts, the better. If this happened to be like a figurine or something like that, you may not be able to position it in a way that there are no undercuts at all, and you may just need to work that out in the end. But for now, I think we can do a slightly better job. And so what we can do to move that is we can use our next option, which is rotational axis movement. So right now it's turned off. So if we turn it on, we can gently just kind of rotate this around so that we can still try and see the end of this until we get to the other end. And then when we hold down our control key, we can actually move that rotation center down to somewhere where it's a little bit more convenient and maybe with a little bit less undercut. So that looks pretty good right there. Let's just rotate back around again and see if everything looks okay. Let's look at our Y. I think we've buried it in there. Okay. Take a look around there. Oh, that looks pretty good as well. So I think that I'm okay with that. So there shouldn't be any undercuts. There's a little bit of red showing at the end there, but that's not a big deal. I'm sure we can work that out in the end. And that's looking pretty good. So let's turn that back off again. Here's another good example of when we should try and get rid of undercuts, or try to align our model better so that we can alleviate as many undercuts as we can. It's important to remember that some models, it'll just be impossible to do that, and you may end up having to remove it by other means, maybe after the part is finished, or breaking up your part into several pieces. But we want to try our best to hide that rotational axis inside your component. So at this table leg, which has a bit of a dip here in it, you'll see that just below our rotational axis, we would have lots of undercuts going on, and we'd get a pretty strange looking model in the end. So by using a combination of our interactive rotation and moving our rotation axis, we should be able to get rid of most of that. So In this case, we're going to turn on our interactive rotation on our Z-axis, and we're just going to tilt our model ever so slightly so that we end up just putting it right about there. And then what we're going to do is we're going to go back and turn that back to our X, Y, Z view, and then we're going to turn on our rotation axis, and we are going to just sneak this around so we can see it from the proper view that we want. That looks pretty good there. And then what we can do is, holding down our control key, we can just move that rotational axis and try to bury it inside of our component the best we can. And I think that looks pretty good right there. And the only way we're going to be able to tell is to turn off our rotational axis. Oh, we didn't quite get it all buried in there. It's pretty close. So we're going to turn that back on again. And maybe we'll move it this way, back in the center of our part. Let's turn it back off again. And there we are. It's looking a bit better. So let's look straight down on our Z there for a second. Let's turn it back on again. And we're going to do the same thing again. We're going to hold down our control key and we're going to drag it just this way a little bit. Hopefully that's enough to tuck it in there for us. Oh, it's getting there. A little bit farther. And as you can tell, it takes a little bit of work. But a little bit of work in the software will save you a lot of time in finishing. And look at that, we almost have it all the way tucked in there. Just one more time, I think. And we're going to be good. Put there, turn that back off. And there we have now, I think it's hidden in there. And that shouldn't cause us any problems. Now, one more thing I'd like to point out is that because of where our rotational axis is and the way your CNC machine will work, that any details that are really close to your rotational axis may have a hard time getting cut. So just keep that in mind when you're designing a part. Now let's head on back to our handle. And now we need to set our model scaling. Now, right now the units are set to inches. And this is a huge, huge handle. The chances are pretty good that when we imported it in, that it was just imported in based on units. So if we switch it to millimeters, it should be 139 millimeters long, which equals about 5.5 inches. So that seems about right. Now, if we look in our 3D view, you'll see we have a red cylinder, and that represents our actual material that we have. Then we have our blue cylinder, which is our bounding cylinder. And we need to try to fit our handle inside of the red. Or we could go and actually change the material that we plan on using. But for us, we're actually going to see if we can fit it in there. So we can do a couple different things. We can go ahead and just type in some new numbers if we would like. With the lock ratio box checked, that means that if we change the 5 to 5.5 inches to 4.5, then it will scale down the model length and the diameter the same amount. We could scale it to fit, or we could reset to the original size. So let's just scale this to fit inside of our material block. And there we have it. So it's about 4 by 9.4. Now it's always a good measure just to make this a little bit smaller, just in case there's a problem with our material. So let's just make our model length probably about 9.25, and that's pretty good. It gives us a little bit of extra material around it, and that's going to be pretty good, I think. So we can just click OK. Now in our 3D view, you're going to see our handle, and it's inside of our actual material. So we can rotate around it. We can have a look at it if we'd like. Now, not to worry about this little bit of jagginess here at the end of your 3D model. Once the software catches up, it will actually clean it up for us and it'll look just like our handle. So let's look down at the Y again, and that looks pretty good. And we can hide our material block so we can just see the handle all by itself. And that looks pretty nice, I think. That imported in quite well. Now, just for a second, let's go ahead and unwrap this. Remember what I said earlier about how our software works. It actually takes a 3-axis part, which is what this is, and it wraps it around so that the ends touch each other. And in that, the result is that we get a handle from that. And you'll see that there aren't any undercuts or anything like that happening at the end. It's a little piece of extra material there that I'm sure we can get rid of. But we do need to add into this a way for it to stay on the machine. Right now, if we cut this the way it is, it would actually fall out of the machine, and that would be the end of this cut. So what we need to do is we need to add in some tabs. So let's look straight down on the Y again. Now, when we actually brought the 3D model in and unwrapped it, the software created a couple things. It created the flat, unwrapped model of the handle as a component, and also gave us a 0 plane. So if we switch our combine mode to our handle to merge, and then we assign a height to our modeling plane of, let's just say, a 1/2 inch, then what we'll see in our 3D view is a core or a tab built at each end of our handle. Now this obviously is too big because it's starting to come outside of our actual handle. So let's just go ahead and change this to be a 1/4 inch instead and see if that might fit in better. And that looks perfect. So we can just go ahead and close that down. Now we have these tabs so that when we actually do cut this, our cutter will stop at the top of the tab, and this will be left behind to hold our part into place. So all we have left to do now is to go ahead and create some tooling for this. Okay, let's take a second and go over to our toolpaths tab to create our tooling. Now the first thing we need to do is to make sure our material setup is correct. So we're going to click there, and our diameter is like it is when we first set up our material, which is 4 inches. Our bottom left will be our XY datum. We're going to be centering off the center of our cylinder. And the model position in our material means that we have a little bit of extra material outside of our model just to cover any inconsistencies in our cylinder. Our rapid Z gaps above the material, you need to set these up that are safe and appropriate for your machine. And then our start position is going to be a 1/4 inch above our material here. And that should be okay for our setup. And we'll click OK. Now, because it's a 3D component, we are actually going to create 2 tool paths, one that will be a 3D roughing pass and one that will be a 3D finishing pass. So let's start off with the roughing pass. We're going to select a tool, and we're going to use a 1/4 inch bull nose. And we're going to go with these settings right now. But once we have them over here in our toolpath, we're going to edit those just slightly. So we're going to change a couple of these, and we're going to change our step over to be 40%, our pass steps to be a 1/4 inch, and everything else here looks great. So we're going to click OK. We're going to cut our full model boundary. We're not going to have any boundary offset, and we're going to leave a little bit of material behind just in case we have any chipping, and this will allow us some material to remove also when we run our finishing pass. We're going to use Z-level roughing. We're going to profile the last cut level by level, and we're going to go along our X. We don't need any ramp or plunge moves, and we're going to go ahead and name that 3D roughing, and we'll calculate it. And now we have the option to preview our toolpath, which we always should. So let's preview that visible toolpath. And you'll see that it's roughing it out and then rewrapping the roughed out relief model. And there we have what it's going to look like when it's all done roughing. That looks pretty interesting. So let's look down again on the Y. Let's close that. And now we're going to go in for our 3D finishing. In this case, we're going to select a tool, and we're going to use the same 1/4 inch tool we did before. We'll select that. We're going to make those same edits, or some different edits actually. The step over, we're going to change to, or we're going to leave it at 10%, which is perfect, and everything else is great. We're just going to go with that. Okay. Again, we're going to limit it to our model boundary, no boundary offset. And in this case, we're actually going to use our raster to finish this off. And right now, the raster angle is set to 0. So our tool will go across the full length of our handle, and then it will rotate our step over distance and then go back again. And it'll do that all the way around the 360 degrees. If we decided to make that 90 degrees, then what would happen is we'd do a full rotation and then move down the handle, full rotation, move down the handle, full rotation, move down the handle. In our case, we like the 0 degrees better with our machine, and we're going to go ahead and click finish. Obviously, you can choose whichever option suits your machine the best. We're going to calculate that. That'll take a minute to calculate. And there we have it. You can see that our nice dense finishing toolpath is right in the middle of our really roughing pass. So if we preview that visible toolpath, we'll see it previewed as a flat relief. Then we'll take that preview and we wrap it around, and we have a nice finished part. Now we use the same tool for both of these, and I think the surface finish is quite nice. So I don't think we need to go in with even a smaller cutter to clean that up. It looks really, really nice. I'm quite happy with that. The detail is good. It all looks nice. And we can easily fix where our tabs go in and out of our actual handle. So I'm pretty happy with that. Now what we can do is go and save off these toolpaths. Now this is the step where we get to choose our post-processor, and you're going to want to make sure that your post-processor that you choose supports wrapped toolpaths. So if we take a look in our post-processor list, if we go down to the Mach 3, as a good example, there's the Mach 3 wrap X to A or wrap Y to A. And in our case, because we have wrapped it, taken the Y-axis and wrapped it around, then we actually want to use the Mach 3 Y to A post-processor. These are both the same tool, so we can go ahead and save these off together if we'd like to into one file, and we can save this off. I'm not going to do that because, like I'd said earlier, we're not allowed to share this model. So what I would suggest you do is to go out and see if you can source a model for yourself and give it a go. So let's close that down. Let's hide our preview and turn off our toolpaths. Now with that, that ends this demonstration. I hope you found it useful and helpful. And if you need any more help, there will be a few related videos below that I'm sure will help get you sorted out.